Hey guys and girls, and welcome back to our course on Tableau. In this session, we're going to go over one more key concept in terms of dimensions and measures, and it's very crucial that we understand this concept because it's, again, going to build on our understanding. So get out your notepads, get out your Tableau, and let's follow along here. Dimensions, as we know normally in Tableau, are descriptive fields. They're the ones that are going to be doing the grouping, whereas measures are the ones that are going to be the ones that are being grouped by. So we can see that measures are normally numeric fields and dimensions are usually descriptive fields, right? So that much we know from our previous session. Now what we're going to cover in this session is the difference between a discrete and a continuous field. And discrete and continuous, very first, right off the bat, is differentiated between their colors in the data pane. Discrete fields are blue by color, and this has nothing to do with their data types. It's just what I want us to understand is that they're blue, and we can see that whether they're true or false, ABC, numerical, doesn't matter. If they're blue, they're discrete, and if they're green, then they are continuous. And I can see already you're probably thinking that since it's blue, it's a dimension, so all dimensions must be discrete, and since a measure is green, all measures must be continuous. But that is definitely not the case, guys. When I was first learning Tableau, this was a very common misconception that I had, and it was an assumption that I made that kind of forced me to learn the hard way in terms of how things actually worked in Tableau. So I just wanted to point out that example because it's important that we see it right off the bat. Just because a dimension is blue does not mean that a dimension is always going to be discrete, and just because a measure is green does not mean that all measures are going to be continuous. So that being said, let's see the difference between them and why it's important. So let's go ahead and take a look at discrete fields first. Let's go into our dimensions and grab something that we can see as an example. Let's take a neighborhood here and let's drag that onto our rows. The very first thing we're going to see is that we have a list here of all the different neighborhoods that we have within our data set, right? And we can also see that neighborhood here has a heading. Okay, if we were to take the same neighborhood and drop it into columns, we can now see that we have a column view of all the different neighborhoods, and we can also see we have a neighborhood heading. All right, now if we were to take the neighborhood and we were to drag our neighborhood out of the columns and into color, we could see that we have all these different colors. Now what's important to understand is that all of these are individual colors per neighborhood. So we could see that neighborhood Allerton is a light blue, Alphabet City is a dark orange, Annandale is a light orange. All right, we can see that each individual neighborhood value has its own color here. Now this differs when it comes to comparing discrete and continuous. So what we just saw are discrete. So first things first, whenever you have a discrete field, they always have a heading. All right, and when you take a discrete field and you drag it onto color, for example, they will all have their individual colors and they're very specific. All right, East Harlem is pink. All right, so let's go ahead and take this out. Now the way that this differentiates from continuous fields, let's go ahead and drag a measure here. Let's take our continuous measure, which is green. So we have a beds. Let's take that and drag it into rows. Now we can see that the pill is green this time, it's not blue, so that's how we know it's continuous. Just because it's green does not mean it's a measure, although that looks like the case, and we'll see why in a second. Continuous fields in Tableau are shown as axes on our visualization. They're not headers. So as you can see, before we had our neighborhood as a header, we saw all the different lists of neighborhoods and we saw the neighborhood header here. Instead, in this case, since it's continuous, we're seeing that beds is actually an axis. So if we were to drag our sum of beds and drag it into columns, we see that again, we see an axis, it's an x-axis instead. All right, and we have a blue line representing a total sum of our different number of beds. All right, so it's not actually individual, it's more of a first to last, 0 to 75k. Okay, that's one key differentiator between discrete and continuous fields, is that continuous fields will show axis, all right, when you drag them into different rows and columns, whereas discrete fields will show headers. All right, now furthermore, let's go ahead and take our sum of beds and drag that into color like we did for our discrete field for neighborhood. We see that it's just one color. It's not 75,096 different colors because it's actually a total sum of beds, and so it's continuous, it's first to last. It doesn't make sense for us to have individual colors for each bed value, if that makes any sense. If I was to look at this and see the colors, we see only one color instead of all the different colors for neighborhoods. All right, so let's take another example. If we were to take, for example, availability 30 and drag that into rows, we can see again, it's a sum and it's saving us the total availability 30, which is 311,026, and availability 30 is an actual axis value, which is the y-axis here. And on columns, we can see that it is the value for the x-axis here. Let's go ahead and see again, if we were to take a dimension and drag that same into rows, we could see, if we add all members, we can see that list, and we see the actual individual line items value by value, and we have a header, which is name. And for columns, we could see the individual columns for each value, and we can see we have a name header. All right, and in both cases, you're not seeing name on this side for columns, and for rows, you see it this way because it's not for axis, right? It's only a header. So even in the case of columns, we see a name as a header, and in the rows, again, we see a name as a header. They're both going along the top. So that's how you know that it's a discrete field, because it's actually showing individual values, and it's also showing the header. Whereas in the case of a measure, we could see the number of bedrooms, for example, we're seeing bedrooms as an axis. And if we drag it up on the columns, we see again, it's an axis because it's underneath. So it's showing a chart value. The other thing that discrete and continuous kind of show, like I said, first to last, we see 0 to 56K. It would make no sense for us to see one bedroom, 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 bedroom in a line. We'd rather see a sum of bedrooms in the view of a total, right? So we see this total sum of bedrooms is 55,096. So for us to organize bedrooms at different rows, like bedroom 1 here, bedroom 2 here, bedroom 3 here, doesn't really matter because it's continuous. It's a first to last, it's a total sum anyways. So whether we have bedroom A here or bedroom B here doesn't really make a difference. All right, so let's go ahead and drag that off. Whereas in the case of a name, if we were to see dimensions, right, we brought in our name dimension, and let's put that on rows, we could see that we have a certain list here. So the order is for individual items, and each one is very different from the other. Now let's go ahead and see if we were to convert a continuous into a discrete, what happens. So first things first, let's go ahead and take, let's see, first review, which is numeric, right? Let's go ahead and drag that into rows. We could see that the sum of first review, we can see that there's 1.6 billion records, right? They're coming in as reviews, and that's the sum of the first review. If we were to take this value and we were to click the down arrow and convert it into a discrete, all right, we will see that we now see first review as an actual text value rather than that graph representation. And that's another difference between discrete and continuous, is that continuous values represent a graph or a visual representation over time. So things like totals or adding, you will see graphs in those cases for continuous, whereas in discrete, you will usually just see one value or just a total. So if I was to take this and convert it back to a continuous, we could see that whole graph to give us that visual representation. And we can also see that it's green. We can also see that it actually has an axis value. Whereas if we were to convert this into a discrete, we can see that the axis is gone and we now just have a header and we have a total without any visualization representation. So these are the key concepts between continuous and discrete, and the reason for their usage are very important, and they can actually differentiate the way that your values are calculated, as well as how those values are represented as a visual representation in your view. So when you think discrete and continuous, I want you to think in terms of how they look visually, whereas dimensions and measures, I want you to think of them as grouping and aggregating. And that is the difference, guys. Dimensions are grouping values, measures are aggregating values, whereas continuous values are showing over time data. All right, they're showing a first to last kind of a view, and discrete values that are shown within a visualization are usually just a text. All right, they're usually a list of values. Okay, that being said, guys, I'm just going to go ahead and reiterate that I want you to take notes while you're looking over this, and I want you to try this out on your own. Try taking a field and converting it from a discrete to a continuous. And again, the way you can do that is you just click the down arrow on the actual pill, and we can see that it's blue here, so it's a discrete. If we were to click this down arrow and convert it to a continuous, it should turn green. And that's how we can see. And the byproduct of that visually will also reflect and the differences between discrete and continuous. So I want you guys to really run this idea home and go ahead and ask questions of each other, ask questions of me if you don't understand something, if you want me to clarify something. I will be checking the comment section very often and frequently to address any gaps in understanding that you may experience. Alright guys, so that being said, I'm going to wrap up this lecture. In our next section, we are going to start looking at a bar chart in Tableau and how the visualization process in Tableau actually works. And although we've seen a small example here and there and how these things come together, in our next session we're going to dive into bar charts and how Tableau actually processes data to come up with these bar type of views, and how the different types of bar charts can actually impact your visualizations, and how to customize your bar charts as well. So all these things are coming up in future lectures, guys. I want you to really watch these lectures a few times if you need to, because these are key understanding concepts. So you don't really need to understand how discrete or continuous really works, but what you do need to understand is the differences visually, how they look within our views. Alright guys, so that being said, I'll see you in the next section, and if you have any questions, again, reach down in the comment section below, and I'll see you in our next session. Thank you.